Functions. A relation is a correspondence between two sets. If x and y are two elements, one from each of these sets, and if a relation exists between x and y, then we say x corresponds to y, or that y depends on x, and we write x arrow y. So a relation is a correspondence between two sets. Okay. So now when we look at that idea there, it's just we're talking about, in a sense, ordered pairs, so to speak, and we've dealt with those quite a bit, like an x and a y. Okay, that would be an instance that we've dealt with previously. So that would be a relation. Okay, now take a look below at this next definition here. It says, let x and y be two non-empty sets. A function from x into y is a relation that associates with each element of x exactly one element of y. So for each element of x, exactly one element of y. So when I have that instance with any relation, it's called a function. All right, so if you look below here, this problem says state the domain, and that's down here. State the domain and the range for each relation. Then determine whether each relation represents a function. So again, if it's going to be a function, it has to associate with each element of x exactly one element of y. All right, so let's take a look at this. So I'm going to look at each x element here, and that would be here. So I take Sam, for instance. And does Sam go to exactly one element of y? And it does. It only goes to February 3rd. Okay, now I'm going to go to Max here. Now, does Max only go to one element of y? And it does. It only goes to February 3rd. So then I go to Sue. And does Sue go to only one element in y? And it does. It only goes to July 8th. So then I would say this is a function. Now, this problem didn't only want me to do this. It also says state the domain and range of each relation. Now, the domain is all of the first non-empty set. And that's kind of how they refer to that when they talk about this idea of domain. So this one would be all my x's, in a sense. That would be my domain. And then all my all my y's would be my range. So I'm going from this set here is my domain. So that means, now I'm just going to write DOM to represent domain. And you have to use these squiggly brackets if it's a set you're labeling. And I'm going to write Sam, comma, Max, comma, Sue, and squiggly bracket. I use these squiggly brackets when I am actually talking about sets. Now, they're not really squiggly brackets. They're called braces, but I just think it's more fun. So anyways, now we need the range. So the range is where my domain is being mapped to, which is here. So that means my range is going to be, and I'm just going to type RAN. My range is going to be January 18th, February 3rd, July 8th. And that's my domain range, and then we know this one is a function. Okay, let's move on to number B now. So I just rearranged it a little here. Didn't have enough room, so here we go. So now for number B here, let's talk about this one here. So this one, let me identify the domain first, because that's what the first part says. I went out of order on the last one, but I won't this time. Okay, so this one says state the domain and the range. So the domain is all of the first components. So my x's. That's another way we represent or talk about domain is all possible x values when I'm dealing with x and y with functions. Okay, so this is going to be, there's my first component. That's a -3, a 1, a 2, and a -3. So that domain is going to be all of those values. So I'm just going to write domain here. And that's what that represents. I use my braces. And then they usually go in order when you can. Now with names, you can't. There's no order to that. So -3, 1, and 2. There's the domain. And the range then is going to be all the possible y values or second components. And that's what this is here. So that'll be 0, 8, 8, 1. Now notice too, even though I have duplicates of the same number in some of these ordered pairs, I still only write it once. Okay, so I have 0, 1, and 8. And then I also go in order when I can. Now I have to determine if this is a function. So in order to be a function, it says a relation that associates with each element of x exactly one element of y. So now I'm going to take a look at that component here. So that x, which is -3, so I just go to my domain here, so I'll try -3. So -3 here goes to 0. And do I have any more? Yes, this -3 goes to 1. So this tells me it's not a function because -3 goes to 2 different y values. And that's what that means. That's not exactly one y value. Now think about this here. If I look at the second, these two middle ones here, 1, 8 and 2, 8, this 1 in the x value, or the x set, excuse me, goes to exactly one element, right? Because there's no other ones. And this 2 goes to exactly one element in y as well. Even though these are the same here, that means nothing here for function. So therefore, it doesn't violate there. The only violation, the only reason why this is not a function is because this -3 goes to 2 different y values. So this is not a function.